Chapter 14 begins on page 329 in the book. We're going to be discussing percentage strength and ratio strength. So anytime we are looking at the strength of a medication, like for example, you can see that this Voltaren gel has a 1% strength. Okay, this sodium chloride bag has a 0.9% strength. So anytime we're looking at a strength, that is telling us that there is a certain amount of medication or active ingredient per every unit of volume or weight of the total amount of medication. So when we're looking at percentage strength is always interpreted as an amount of active ingredient in every 100 milliliters or 100 grams. Okay, now depending on the type of drug that we're looking at, that's going to determine which units that we're using. So for example, this is Voltaren gel. I'll show you this here closer up. So Voltaren gel here, this is a solid or semi-solid, if you will. So this is going to be in grams, okay? So the active ingredient that we're looking at in this gel would be in grams, and the total weight of the gel would also be in grams. So this would be an example of a weight per weight calculation. So you can see here we have, if we have a weight per weight, it will be grams per grams. Now this sodium chloride solution, it is a liquid, but the active ingredient that was dissolved into the base solution was in a solid form, in a powder form. The sodium chloride was in a powder, so we would have measured that in weight, and then in the total liquid, we're looking at a total volume. So this would be an example of a weight per volume solution. So the units that we would use here would be grams per milliliters. Now, if I would have had a liquid active ingredient and diluted that down with another liquid to have a total volume, that would be an example of a volume per volume medication. So it just depends on which drug you're looking at, which units we are going to use. And this is going to make a little more sense once we get started on some of these examples here. But I do want you to understand that you can have a weight per volume, a volume per volume, or a weight per weight drug, depending on the dosage form. Now, percentage strength is used a lot when we're looking at IV solutions, just like that bag of sodium chloride I have here. So we're going to go over some of these common IV solutions. We have talked about these once before this quarter, but it is really important for you to know. So normal saline is going to be 0.9% sodium chloride, just like that bag that I have here. Half normal saline is half of 0.9, so 0.5% sodium chloride. Anytime you see a D in an abbreviation for an IV solution, that is going to indicate dextrose. Anytime you see W, that is going to indicate water. So here we have a 5% dextrose solution in water. And then here we have a 10% dextrose solution in water. Here we can see that we have D for dextrose in S. Once again, that's normal saline. Normal saline is always 0.9%. So here we have 5% dextrose in 0.9% sodium chloride. Lactated ringers is a base solution that has a lot of different ingredients in there here. So anytime you see LR or RL, that is going to indicate lactated ringers or just ringers lactate. It means the same thing. So get familiar with these abbreviations if you're not already. You will be having to interpret orders with these abbreviations in them, especially if you're working in a sterile compounding pharmacy, or you see these a lot in hospital pharmacy especially as well. Okay, so let's jump into percentage strength. I gave you all the math lecture worksheet. I've also indicated in this top left corner that percentage strength, we always indicate as an amount, which is our X over 100. Now the X is always going to be our active ingredient, and the 100 is always going to be either the total volume or total weight of our drug that we're looking at, okay? So for example here, on this slide, I have a 10% weight per volume solution. So anytime you see a percentage strength, that number that is given before the percent sign, that is your X, okay? So a 10% solution would mean we would have 10 grams in this case, because we're looking at weight on the numerator, 10 grams of active ingredient in every 100 milliliters. We have milliliters on the denominator here, so 100 milliliters of total solution. So the easiest method for calculating the amount of solute in a specific quantity is going to be ratio and proportion. So the method that we've been doing pretty much all throughout the quarter so far. So let's just take a look at this bag real quick that I have. So I have a 0.9% sodium chloride injection, okay? So what that means, like I told you earlier, this is a weight per volume solution because the powder active ingredient was measured in grams and then it was dissolved into the liquid, which is measured in milliliters. So I have a 0.9% weight per volume solution. Now, like I said, this is a percentage strength. Anytime you see a percentage strength, just take this number here, 0.9, and put that over 100. We're just taking the number, that's our X, putting that over 100. Since this is a weight per volume, remember my units of weight are always in grams. My units of volume are always milliliters. So here I have 0.9 grams of my active ingredient, which is sodium chloride, in every 100 mils of solution. My pen is running out here. Let me grab another one real quick. Sorry about that. Okay, so I have 0.9 grams of my active ingredient, which is sodium chloride, in every 100 mils of solution. Now, if I wanted to find out how many grams of active ingredient are in this bag, I would have to set this fraction equal to the total volume of my bag. Now, in this case, my bag is already 100 mils. So if I set this equal to X over 100, well, that's still just going to give me 0.9. So I know that in this 100 mils, there are 0.9 grams of sodium chloride. So let's take a look at number 1 here. It says how many grams of dextrose are in a 3,000 ml bag of D5W. So we have to understand our abbreviations first to understand what this means. So this means that there are 5% dextrose in water. That is our solution, okay? So I know my percentage strength. So anytime you see your percentage strength, remember, set that up as a fraction. Just take your number, that's your X. So in this case, 5. And this is another IV solution, so we're always going to assume that those are weight per volume. So 5 grams of dextrose. And remember, it's percentage strength, so X over 100. So in every 100 mils of solution. Now it says, how many grams of dextrose are in a 3,000 milliliter bag? So if we're using ratio and proportion, we can just set this equal to 3,000 milliliters and then solve for X. So 5 times 3,000, that's going to give us 15,000. set that equal to 100x. Now we divide by 100, divide by 100. That's going to leave us with 150. And remember, we have grams of dextrose. Now, what I want you to do is solve number 2 on your own. But take a look at number 2 is asking for how many milligrams of sodium chloride are in 750 mils of D10NS, excuse me. So also, they're asking for milligrams of sodium chloride. So first of all, interpret this abbreviation, figure out what this means. Now here we have dextrose and normal saline. So keep in mind, they're asking for sodium chloride. Now when you set this up in a fraction, remember, we are always solving for grams here. So once you solve for grams, then you're going to need to convert your answer into milligrams. So we'll go through number 3 here. A physician orders 2.5 liters of 4.5% Travasol to be used in a total parenteral nutrition bag. How many grams of amino acids will be provided? So we know we're looking for grams of our active here. We know we have our percentage strength, and we also have the total volume of the bag. So anytime you have your percentage strength, start with that. Let's turn that into a fraction. Once again, if it does not specify the type of drug, we're going to assume weight per volume. So here we would have 4.5 grams of amino acids in every 100 milliliters of solution. And we can set that equal to our total volume. So they're ordering 2.5 liters. Well, I can see that here I have milliliters. So I need to first convert my 2.5 liters into milliliters. So if I'm going from liters to milliliters, I'm going to move my decimal 3 places to the right. So that would give me 2,500 milliliters. So 2,500 milliliters. Now I can solve for x. So we're going to take 4.5 times 2,500. That gives us 11,250. Set that equal to 100x. Divide by 100 here. Do the same to the other side. And that leaves me with 112.5 grams of amino acids. Now, I want you to do number 3 on page 333. So very similar to the one that we just did here. Actually, that one is only in milliliters, so it should be pretty similar to number 1. And then number 7 on page 335, complete that, show your work on this paper as well. Very similar to the one that we just did. Okay, so in your assignment this week on practice problems B, it has you interpret the following medication. So on the problems in which it wants you to interpret, I just want you to write out what this actually means here, okay? So for example, we have a 15% neomycin solution that is a weight per volume. So 15%, we know that that means that there are 15 grams of neomycin in every 100 milliliters of solution. So that is all I want you to write out. I just want you to write it out in words rather than in a fraction. So we have 15 grams of neomycin in every 100 milliliters of solution. So that's what I want you to do for the first part on each question on practice problems B. Now the question says, how many grams of neomycin are in 450 mils of solution? Well, you should be able to solve that based on the two examples that we've gone through so far. So go ahead and solve 6A now. Now here the question says, how many milligrams of neomycin are in 4 ounces of a 10% solution? So let's see what we know here. We have a 10% solution. If it doesn't specify, we're going to assume weight per volume. So we have 10 grams of neomycin in every 100 milliliters of solution. Now this time we're looking for milligrams of neomycin. So remember, if I solve for my x here, that's still going to be in grams. Okay, so we're going to solve for the grams first, then we'll have to convert to milligrams. Now this time, my total volume is in the household system rather than the metric milliliters here. So I'm going to first have to convert my 4 ounces into milliliters before I can plug that into my volume here. So remember, 1 ounce equals 30 milliliters. So 4 ounces, we would take 4 times 30 here. So 4 times 30 would give us 120 milliliters. So my total volume I have is 120 milliliters. Now I can solve. So I have 120 times 10, which would give us 1,200. And then we're going to set that equal to 100x, divide by 100 here. Do the same thing to this side. So x equals 12 grams. But remember, they asked us for milligrams of neomycin. So when we're converting this here, we need to take our decimal point. When we're going from grams to milligrams, we're going 3 places to the right. So that is going to equal 12,000 milligrams of neomycin. Now this next question says, what is the strength in milligrams per milliliter? Well, we just changed our grams here to milligrams. So I know that there are 12,000 milligrams in 120 milliliters of solution. Sorry, that's a poor one. 120 mils of solution. But they're asking us basically how many milligrams are in every 1 milliliter of solution. So the easiest way to do this, you can simply just divide this fraction, and that will give you your milligrams per mil. Or if it helps you to see this visually, just set this equal to x over 1 mil. So we'll be solving for milligrams per 1 mil. So if I take my 12,000 and I divide that by 120, that leaves me with 100 milligrams on top. So my strength would be 100 milligrams per every 1 milliliter. Okay, now B, how much neomycin powder is needed to make 120 mils of a 25% neomycin solution? So once again, we have our strength here, and we have our total volume. So we're going to be looking for how much neomycin powder. So we're going to be looking for grams of neomycin powder. So based on what we've done so far, go ahead, pause the video, and solve B. Once you have solved B, then we'll move on to number 8 here. So a physician orders 1.5 liters of a 20% neomycin solution to use for irrigation of a wound. The available neomycin is in 0.5 gram tablets. how many grams of neomycin are needed to fill the order? Well, we have the strength once again. We have our total volume here. So remember, 20% means 20 grams of neomycin in every 100 milliliters of solution. Set that equal to our total volume, which 1.5 liters. We're going to have to convert that into milliliters. So going liters to milliliters, we move our decimal 3 places to the right. So this would be 1,500 milliliters here. So now we can solve. Take 20 times 1,500 gives us 30,000. Set that equal to 100x. Divide by 100. That leaves us with 300 grams of neomycin. Now it says how many tablets are needed. Well, we know that our tablets come in 0.5 grams each. So if we know that one tablet is 0.5 grams, we can set that equal to what we need here, which is 300 grams. So when you solve for x here, that's going to be a very, very large amount of tablets. It wouldn't be ideal to use those tablets. We would probably want to order higher strength or see if we can just get the neomycin powder. But regardless, for this example, go ahead and solve for how many tablets are needed for that order. And then after you have solved B, go ahead and solve number 9 as well. So how many mils of D5W? So you're going to need to first interpret that. What does that mean? Should be administered to a hypoglycemic patient to provide 200 milligrams of dextrose. So now this time we have the amount of active ingredient. So you're going to have the amount that you need on top. You're going to be solving for how many milliliters of solution. So you're going to use your percentage strength to set up your first fraction, set that equal to your milligrams are going to be on top, but remember our percentage strength here, our unit that you should use over here would be grams. So you're going to need to first convert this into grams before you plug it into your equation. Okay, number 10. How many mils of a 15% solution can be made from 125 grams of neomycin powder? Well, our 15% solution, we're going to assume that that is a weight per volume. So we have 15 grams of neomycin in every 100 mils of solution. Now this time it's asking us for how many mils. So our X is going to be on the bottom, can be made from 125 grams of neomycin. So that's going to go on top. So if we solve for X here, 125 times 100 just gives us 12,500. And then we set that equal to 15x. So divide by 15 on both sides. Leaves us with 833.3 milliliters. I just rounded to the nearest tenth. So now it says, how would the formulation instructions read for this preparation? So let's pretend that we're trying to write a formula to make this drug here. Well, we said that we're making a total of 833.3 mils, and we have 125 grams of our neomycin powder. So we're going to start with our active ingredient. It doesn't tell us exactly what diluent we're going to use, so we'll just be general in this description. So we're going to start with 125 grams of neomycin powder. Now, I'm going to talk about this concept here. So anytime you have a powder and you are dissolving that with a diluent, this powder is going to take up space of its own, okay? It's going to dissolve and it's going to become a volume. Now, we cannot specify for sure how many milliliters this powder is going to take up. So anytime we don't have an exact amount of diluent given to us, but we do have our total volume, we use the abbreviation QS, which means quantity sufficient, which basically means add enough water to get up to, in this case, we have a total volume of 833.3 mils. So we're going to say QS to 833.3 mils with solvent or diluent. Both of these words mean the same thing. Like I said, this doesn't specify what our diluent is, but this would give the technician the instructions on what to do. So first, weigh out your 125 grams of powder, and then you're going to add enough water to bring you up to 833 mils of total solution. Now, this doesn't mean that we're adding 833 mils. That would bring us over that total because this has to dissolve and take up space of its own. Okay, so a few things to review here. I have always hinted on this, but we always assume that the amount of active ingredient is grams unless otherwise specified. And we always assume that the total quantity of a product is in milliliters unless otherwise specified. So like on the examples on the worksheet, I was telling you to assume that we're using a weight per volume unless it tells us otherwise, unless it says it's a weight per weight or a volume per volume. Now, we have not got to ratio strength yet, so I'll come back to this here in a little bit. But I wanted to go through to this slide. So this is what I just discussed, the concept of quantity sufficient. So please make sure that you understand that this is a very important concept, especially as we get into these compounding chapters and as we start working on start editing our master formula for our product. So now I want you to take the time right now, pause the video, go work on practice problems A and B. By now, with the examples that I've shown you, you should be able to get through both of those sections. Once you've finished with those, then come back to the video and then we'll move on to ratio strength here.